Hi guys, this is section 9.5, the Gibbs-Duhem equation. Well, if we have a solution where the solute is non-volatile, sodium chloride, sugar, something like that, has no vapor pressure, we can't measure its chemical potential directly because we can't measure its vapor pressure because it has none. However, what we're going to show in this section is that if we know the chemical potential of the solvent, we can find the chemical potential of the solute, the non-volatile solute. So we're going to start out with something we saw in chapter 6 at section 6.4. Really, I haven't been drinking. At constant temperature and pressure, dG is equal to sum over I of the chemical potentials times dN sub I. Also, same section, G, the Gibbs energy, is equal to the sum over I, N sub I, mu sub I. So if we take the differential of both sides of this, guys, we get dG is equal to sum over I of N d mu sub I plus sum over I mu I dN sub I. These are both equal to the same thing. They're both equal to dG. That means that setting these two equations equal to each other, we see that this term has to be equal to 0. And that is the Gibbs-Duhem equation. Sum over I of N sub I d mu sub I is equal to 0. And what that says is that the chemical potentials of the species in a solution are not independent of each other. So for a binary solution, only two components at constant temperature and pressure, the Gibbs-Duhem equation looks like N1 d mu sub 1 plus N2 d mu sub 2 equals 0. Or we can write this in terms of mole fractions also, by the way, guys. Mole fraction of 1 d mu sub 1 plus mole fraction of 2 d mu sub 2 equals 0. Just think about, okay, so the mole fraction is the moles divided by the total moles. If we divide both sides of this equation by N total, 0 over N total is still 0, we get the mole fractions, same thing. Rearranging this a little bit, guys, we get d mu sub 2 equals negative mole fraction of 1 over mole fraction of 2 d mu sub 1. Now, let's say one of the, okay, so let's say one of those components obeys Raoult's law. So it's, what that means is mu, say component 1. That means mu sub 1 equals mu 1 star, which is the chemical potential of the pure substance, plus RT natural log of the mole fraction of component 1. Taking the differential of both sides, derivative of both sides of this equation, we get d mu sub 1 equals, because this is a constant, this is d mu sub 1 star is 0. We get RT d mole fraction of 1 over the mole fraction of 1. D natural log of x equals dx over x. If we take this, okay, and substitute d mu sub 1 from the Gibbs-Duhem equation by what we just got here, then it works out like this. Notice that the chi-1s, the mole fractions 1, cancel. We get a negative. We get negative RT, d mu sub 2 equals negative RT d chi-1 over chi-2. But, okay, there's a connection between chi-1 and chi-2. They have to equal 1. That means that chi-1 plus chi-2 equals 1, or chi-2 equals 1 minus, this is supposed to be chi-1. Taking the derivative of both sides, d chi-2 equals negative d chi-1 because d1 is 0. That means that plugging, okay, so, or we could say d chi-1 equals negative d chi-2, either way. So we can replace, we see this, d chi-1 with negative d chi-2, and the negatives cancel. We get d mu sub 2 equals RT d chi-2 over chi-2. Now if we integrate both sides with this equation, okay, we get mu sub 2 equals RT, it's constant temperature. Integral of dx over x is natural log of x, so RT ln chi2 plus some constant of integration. And we can evaluate that constant of integration if we take the limit as chi2 goes to 1, pure component 2. So we do that on both sides. The limit as chi2 goes to 1 of mu sub 2 is equal to limit as chi2 goes to 1 of this whole expression, RT ln chi2 plus c. Well, mu sub 2, when chi2 is 1, is the chemical potential of pure component 2, which is just mu 2 star. Chi2 goes to 1, ln of 1 is 0, so this whole term goes away, and we see that the constant of integration is equal to mu sub 2 star, the chemical potential of the pure component 2. Plugging that back into this equation up here for C, we get mu sub 2 equals mu sub 2 star plus RT ln Chi2, exactly Raoult's law. So one component of a solution obeys Raoult's law, all components do.